Hi there and welcome to the video. My name is Lachlan, I'm a Microsoft technical trainer. It's good to have you here. In the upcoming video, we're going to be talking about hybrid networking and a broad set of design and implementation principles that we can look at to ensure that your enterprise network, no matter where it is, can be linked into Azure in a clean and efficient way. We'll begin with VPNs and how to actually get a virtual private network connection established into Azure, because there are two different types of VPN we need to look at. Both site-to-site VPN connections for interlinking two different locations together, as well as point-to-site VPN connections, typically used for end-user devices. We'll also take a little bit of a look at virtual WAN and how you can establish and spread different network connections into the Azure environment with ease. Once we've got that, let's take a final look in the WAN space and how we can deploy network virtual appliances for security and routing purposes. In the video ahead, we're going to be looking at the VPN gateway, how it can be utilized to interconnect your Azure environment through to other locations. But before we actually deploy a connection, an A to B transfer of data, we need to have a place in your environment that it can land. This is where the VPN gateway itself begins. We'll look at a little bit of a planning of the types of connections you can establish with the VPN gateway, just a few different configuration options, as well as a little bit about the generation and SKU options available for the gateway itself. Let's dive in. So when we go to deploy a VPN gateway, planning is really the main thing that we need to consider. There are three different types of connections we can make. Realistically, there's two types of connections. We'll get into it. The first is a site-to-site VPN connection. This allows us to establish any sort of connectivity between one physical location and your Azure environment. But we can also use this for establishing connections between Azure environments. There are some scenarios where we still utilize this, although peering does tend to take precedence nowadays. Additionally, we also have point-to-site connections. Whether you're using a VPN client for a personal device or using a Windows-based device that supports VPN connections natively, these point-to-site connections allow for individual user devices like mobile phones and laptops to connect into your private network and access internal resources. Extremely used for everyone on the go in this work-from-home environment. Regardless of the type of connection you are looking to establish, the main thing is you need a gateway. You need somewhere to land that data. A public IP address for us to reach and something that allows us to traverse into the virtual network itself. Now, before you establish the gateway, you actually do need a dedicated subnet just for that gateway created. One gateway per virtual network. Keep that in mind. Now, we do need a CIDR block of either a /27 or /28. Just depends on what it is that you're looking in terms of scale and the different options for SKU. But as long as you pick something of that size, you'll be more than covered. We'll actually manage the scaling of any compute resources in the back end to ensure that you get the required bandwidth capacity that you have requested. So once you've got the gateway set up, really all you need to do is tell us what gateway you want in there. The big thing that I want you to know before we go any further though, never ever deploy other resources that are not managed gateways in Azure to that subnet. It is designed for the Azure VPN gateway and the ExpressRoute gateway. Those are the only two resources that utilize that subnet. It's named in a special way and it has some special rules around it in terms of how things get provisioned. Provisioning. That's our next step. So we've got a place to land it. Let's create that gateway, the link between our on-prem and our user devices and our Azure environment. To create the gateway itself, name, region, all of those things need to be selected. But there are a few interesting little pieces along the way. VPN type, that one's a big one. We support both route-based and policy-based VPNs, but policy-based is considered more of a legacy system because it doesn't support the latest encryption, supporting only IKE v1. Using a route-based VPN connection supports IPv2 and has support for dynamic routing protocols. Both are essential for keeping an enterprise environment up and running successfully. Other than that, it's really just a matter of picking the right SKU and generation and telling us where you're going to land this. What virtual network is your gateway going to exist in? There is a big thing to remember. 45 minutes is about what it takes to provision a gateway. Most network resources are nigh on instantaneous to make, but the VPN gateway does take about 45 minutes to provision, so don't do it in anger. Make sure you've got it set up, ready to go before you need it. Alright, we have our gateway with a public IP landed in a subnet, which is in the region that we wish to have connected across. What's left? Well, there was that SKU and generation. How fast do you want to go? Generation is the big thing to really think about here. Gen 1 and Gen 2 both offer different scalability options. Generation 1 VPNs start at about 650 megabit, but cap out at 1.25 gigabit for the simultaneous tunnel connection speed. If you want a higher aggregate speed, I would recommend looking at the Generation 2 VPNs instead. They begin at that 1.25 gigabit range and go up and up from there. Both options allow for resizing, at least within a generation, so if you start on a Gen 2 small, you can up that size over time as your requirements change and as more people jump on. But pick and choose what makes sense for you. If you don't know what to pick, always pick the latest generation. Once you've got that, you're ready to go and start establishing connections. In the video ahead, we're going to be talking about site-to-site VPN connections, an easy way for you to establish across the public internet a secure connection, Azure to any other location really. Whether it be a separate cloud provider, a physical location, or a private data center, we're able to establish these secure connections across this public infrastructure in a way that means your data is protected. Establishing a connection does have a few different steps that are required to be taken along the way. We're going to start at a top level, just talking about what the VPN connection setup actually looks like and how you can make use of it. And then I'm going to go step by step, what you need to create and in what order to make everything work. Let's begin. In front of us here, we have a fairly typical setup. On the left-hand side, we see Azure. Virtual network, a couple of subnets, and it has a VPN gateway already provisioned and ready to go. And on the right-hand side, an on-premises network. Resources like virtual machines sit within a network there, but we have established a device at the edge that is able to establish connections with VPN devices. So, what we need to do is establish a handshake between these two so that they know where one another are. We need Azure to know where on-premises is, we need on-premises to know where Azure is, and we need to know what traffic is supposed to traverse across the two. Each of the different steps we're going to take in the provisioning process are all about just establishing these different pieces. What do we do in terms of authentication? How do we know we're connecting to the right spot? How do we know what's on the other side? All of these get answered by creating individual resources that we link together into a connection as a whole. So let's begin with our first one. We're going to need to create something called a local network gateway, which more or less is a simple pointer reference that tells Azure where on-prem is. So this local network gateway, it really is just a true pointer location. It tells us either via IP address or fully qualified domain name where the external site is. If we've chosen an IP address, this one here is effectively just a public IP, something that we can reference and that we can route to across the public internet. Also note the address space that you see down the bottom, the 192.168 address. This tells us what's on the other side. What can we expect to find on the other side of that connection? This is important because we need Azure to be able to set the routes accordingly by default. Of course, we can set custom routes to change what actually goes across this connection, but by default, we want it to work. Now, local network gateway is the first piece of the puzzle. For the second piece, we actually step away from Azure. I need to go back on premises or to my physical site, and I need to configure my VPN device over there. Now, we are very lucky. Over in the Microsoft documentation, there is already a supported list of VPN devices, and there is pre-configured scripts for a large number of popular devices, such as in the Cisco, Ubiquiti, and Barracuda range. Regardless of what you are deploying, make sure you check the documentation first. Someone may have already done the work to get a script to set up and get everything ready. Effectively, what we're going to be doing is running a simple setup that involves generating a shared key, something that your on-premises device will hold, that we can pass across to Azure, so when it establishes the connection, everything links up a-okay. So now we know where on-premises is, we know from the device side that it's configured right. Let's do our final link. We've got our gateway. Let's make that connection. A VPN connection is the wording that you're looking for. It is a particular resource that gets created, and it is a link between a virtual network gateway, a local network gateway, and a shared key, the thing that you generated when you configured your on-premises device. If you have those three things and can establish a connection, you're basically ready to go. So, get everything lined up, all your ducks in a row, and hit create, and your connection will be ready. But ready doesn't always mean working in the way you want or performative. There's always things with networking across the internet. So I do recommend going through and taking a look at some of the diagnostic log options that are available in the Network Watcher space. Different types of validation are available for throughput, for ensuring that keys are working correctly, that synchronization is fine, all of that sort of stuff. We also have simple gateway health probes that you can make use of just to make sure and validate that everything is working correctly. Never presume that everything is fine just because you've configured the bits and pieces in the right order. Always verify and double check that it's all working correctly. So, in a bit of a summary, let's go through the step-by-step. I'm actually going to go back to before this. Let's presume we've got nothing. What do we need to do? We need a virtual network with a gateway subnet. We configure our virtual network VPN gateway and provision that in there. Once that's done, create your local network gateway resource, configure the VPN device, and create that site-to-site connection. Just remember to always verify that everything's working well, and you'll be home free. We are going to be looking at point-to-site VPN connections. These are typically established from end-user devices like laptops and mobile phones and allow us to integrate in with our private networks and let people access the resources they need to. Regardless of the type of point-to-site connection you are establishing, which we do support quite a few different ones, you're going to need to go through some basic setup in order to get things up and running. For example, we'll need a VPN gateway already provisioned in a gateway subnet, ready to go. But once we have that in place, it's all just a matter of pointing in the right spot, giving people the right credential mechanism, and ensuring that everything works with the clients that we support. So let's dive in and take a quick look at how point-to-site VPNs work at a high level, and then talk through some of the specifics. So in front of us, we have a fairly common environment. We have some on-premises servers, we've got some domain services running, and we've got an Azure environment with a VPN gateway already established. Let's run through how a user would connect into our environment here. For example, OpenVPN. OpenVPN is a multi-platform VPN provider, and it is one that we support. We can actually go through and set up a point-to-site connection, potentially from a mobile phone device, into an Azure environment using our gateway there. This allows the user to interface with the environment, be given a private IP in our virtual network there, and be treated like any other private resource. This is extremely useful if you've got someone that needs to access an internal HR site or needs to access something which must be kept on your private network, but they're not able to be physically in an office space. Now, OpenVPN is not the only type of connection that we support. SSTP is also possible, very useful for Windows 10 and 11 devices, and we do support IKE v2 connections. As an example, macOS can make use of that. Regardless of the type of connection you are looking to set up, there's a second part which comes into play here, authentication. Now, depending on the protocol type you pick, there are different authentication methods that will be deemed valid. You can use something like Entra ID, signing in with your Entra ID credentials and then being allowed in the door that way. Great if you've already got your identity set up in Azure. But if you're someone who has your identity in an on-premises store, say an Active Directory domain services store, there's only really two things that we need. One, a connection. For example, we could set up a site-to-site VPN between Azure and your on-premises environment, or we can use something like ExpressRoute. The second thing we need is a radius server. For those that work in this Wi-Fi space, you'll be intimately familiar with radius. It's been around for forever at this point, but we still can make use of that and leverage it when we're logging in with a VPN connection. It's extremely useful still. So if you already have your radius infrastructure set up and you're looking to use on-premises identity stores for authenticating people into the environment, you can continue to do so. When you're ready to, or at a time that is appropriate, you can always make the switch across to Entra ID native authentication to keep things a little bit smoother. So regardless of the authentication method or the connection type that you choose, you need to go through just an initial piece of configuration to make sure your point to site is actually going to work. And it is pretty simple. Head to your virtual network gateway, scroll on down, and hit that point to site button. From there, you can configure a few different settings, including one of the more important ones: where are your point to site connections going to land? You will require a subnet that they can make use of. So for each user that needs to be connected via a point-to-site connection, you need a private IP available for them. Think about the number of simultaneous users you have. Is it going to be 10, 100, 1,000, 10,000? Whatever it is, make sure you've given them breathing room so everybody can get connected. Additionally, some more resilient gateway deployment options, such as an active-active gateway, will require additional IPs for users to be able to fail across easily. Make sure you've taken this into account when you're going through and deploying things out, as the minimum range will change and the number of IPs required for each user does come into effect. If you set everything up, you've got your authentication in play, users will be able to securely connect into your environment from anywhere that you specify. We are going to be looking at VPN gateway resiliency, how you can get your gateway into a better place through a couple of simple configuration changes. Now we're going to jump straight into it because the two ones that I want to cover are covering both types of regional scenarios that we support in Azure. Now the first one I want to look at is how to deploy your virtual network gateway in an availability zone format. On the screen here, you can see that we have two gateways, Instance 1 and Instance 2, deployed across two different availability zones. Availability zones split different power and water and different data centers physically from one another to ensure a high level of uptime. This means that we can have all of our traffic come into one common location, but get redirected accordingly in between the different gateways. In the event of a physical failure or some sort of configuration issue, we'll be able to actively fail across through to one of the other instances that's already up and running. This is the easiest way to get things up and running in your environment and ensure that high level of uptime. But not every region in Azure has support for availability zones. There are some pretty strong physical requirements that tell us whether we can do that. So in regions that this isn't an option, I'd like to present something a little bit different. High availability is a simple flick switch that you can change when you configure and deploy your VPN gateway. Note that the left, the default, is to have it in active standby mode. This is simply because on premises you will only require one connection to be established. It's nice and easy to set up, and in the event of a failure on our end, we'll just simply cut the active line and move across to the standby. Now for clients and for customers that sort of cutover is not acceptable, or you just simply need a higher level of uptime, look to the active deployment model instead. You will need to go through and establish a couple of extra connections on your side, and there's some highly available architectural documentation you will need to follow. But it means that your VPN connection will stay up in more scenarios. Whether it be one of your devices going down, or something going awry between your device now connection, or something going awry on the gateway in Azure, doesn't matter. You've got 4 potential points, and if any one of them goes down, there will always still be different pathway connections. Establishing the different topology setups for this does require some different planning. So, as I said, make sure you go to the Learn documentation and take a look at some of the architectural recommendations around this, just to make sure that everything works smooth. If you're looking for that higher level of availability, don't forget to configure these options, and no matter where you are deploying, you'll always be able to have it up your sleeve if you need it. In this one, we're going to be looking at Azure Virtual WAN. It's got some interesting things available to it. The wide area network. It allows us to spread further across regions, across different sites, sort of just mesh everything together in a clean and manageable format. Whether you are using an existing wide area network to physically interlink multiple sites already, or this is your first time looking at a WAN, Azure offers some interesting solutions and capabilities that will really assist you in spreading your wings as an enterprise. We're going to start with just a little bit of what is, and then go through how to actually choose things like the right SKU, plan out the right address space. There's a couple of choices you need to make along the way just to make your journey to using a wide area network smooth. So what we have here is an Azure environment spread across multiple regions, a company with branch sites all over the place. We've got users that need to connect in. This is a complex setup. Getting all of this to work harmoniously is a challenge, even at the best of times for the most skilled network engineers. But a wide area network leverages some interesting technologies to ensure that everything sort of just works in a little bit of an easier way for you to manage. Let's start just with region A on the left-hand side there. We can see that I've got my HQ on the left and a branch that I need to connect into. They're both in the same city, but at this stage, there's no real way to connect the two together. What we can actually do is establish connections from both the headquarters and the branch via VPN, ExpressRoute, one of our partners, whatever mechanism you want to use, and connect that in to your WAN here. The WAN then holds routes that allow us to traverse traffic sort of wherever it needs to go. If I am a user over in the branch and I need to be able to connect into a virtual network, not a problem. Same region, simply traverse up through the WAN and into the virtual network. Beautiful. Maybe I need to reach something that's over in my headquarters, something in a physical location. Traverse across the WAN and you can reach it. It allows for us to interconnect different types of connections in a simple manner. Now, where this really shows off is where you have multiple of these virtual WAN hubs across different regions. Let's say I've got a secondary region here, and I have users that need to connect in via point-to-site VPN connections. Not a problem. Virtual WAN supports ExpressRoute, point-to-site, and site-to-site connections simultaneously. So if you need to interlink lots of different locations and different types of users and connections, you can simply use the WAN to route that traffic in a central manner. All of these branches can have their own dedicated connections via VPN or ExpressRoute, whatever works best for them. They're able to access resources in Azure, and if you interlink the two together, you're able to interlink between those hubs and have traffic traverse from one region to another. Extremely useful and extremely flexible. Great for any enterprise that is spread across many locations. Now, when you deploy your virtual WAN hub, there's really only one kind of big choice to make. Of course, we need to know what region you're deploying to, what resource group, the standard stuff that we need for any resource. But you need to make the choice. Are you picking a basic virtual WAN or a standard virtual WAN? Honestly, this just depends on the business. Standard virtual WANs support all different types of connections, including that ability to go from one hub to another. Very useful. But not every business needs that. Maybe you're a smaller business that primarily exists in a single city or a group of cities and use only VPN connections. Go a basic. Site-to-site VPN connections are fully supported. Depending on what you need, there's different SKUs or t-shirt sizes available for you. Now, regardless of the SKU you pick, the next thing you need to choose is the private address space you're going to allocate to the hub. Just like we would with a virtual network, you need to give some sort of place to land private IPs if we need to put anything in there. Say we're deploying a virtual appliance or looking to spin something up. The hub needs to have some sort of private IP space to work with. Now, this is a little bit more flexible than with a virtual network. There's no need to explicitly plan out, say, subnet divisions or anything like that. All we need to know is the full pie. What are we going to choose as that big CIDR block that represents your regional hub? Once you've got that, it's a managed service. And that's the biggest thing of all. Virtual WAN is not an appliance you deploy. It's not something you're just going to spin up and create and then have to patch and upgrade. It is a fully managed service. By deploying this and connecting into it, we will manage it on your behalf and ensure that it is up and running and functional. All you need to do is pass the configuration along and tell us how you'd like it to work. And there is one fun little thing that I do want to talk about with virtual WAN. That's this. Cross-tenant routing. We actually have the ability to connect other tenants' virtual networks into a virtual WAN hub. This is similar to what we would do with a peer across different subscriptions or different tenants. Now, where this can be really useful is if you are a provider that is offering a service or some sort of managed environment service to consumers. If you wish to connect into your environment or establish a connection from their environment into yours, you can actually do that directly into a virtual WAN. It's very easy to be able to get this up and running, but it's not something that happens immediately. There are certainly some security-based steps that you'll need to go through, but if you're looking to connect together, it's extremely useful to have this option. Regardless of whether you are keeping everything within a single tenant or going multi-tenant, it all comes down to routing. Just like it does with everything else in the virtual network space, we need to make sure that things hop to the next thing that they're supposed to reach. Also, just like with virtual networks, virtual WAN and vWAN in Azure uses a route table to control where this next hop goes. So, what you'll actually do is propagate a route table at the hub itself. What's interesting about this, though, is that it gets associated and then propagated. That propagate word, it sits at the hub and it gets pushed out elsewhere, so everything around it knows what's sitting in the hub there. Central Hub has an aggregate throughput of about 50 gigabit, so you've got a lot of traffic to work with, and potentially you're interlinking many different locations together. By setting up these different route connections, you'll be able to establish where everything is. Define it in your table, tell us where you need to hop to, and we'll make sure that it gets pushed out accordingly. There's some easy management setup of how to actually get this going within the default routing table, and I recommend looking at learn.microsoft.com and the documentation for more specific details about how to configure this and make changes for your environment. We are going to look at how to deploy a network virtual appliance into a virtual hub. Now, this wording is pretty technical, it's fun. There's a lot of lingo kind of being thrown around. But it's important to know sort of the why of why you're doing this. Network virtual appliances represent, well, virtual versions of physical network appliances that we would make use of. Firewalls, security appliances, there's a whole range of different things that we can put in place. So we're going to look at two different steps, a simple management procedure and how to actually deploy the NVA into your virtual hub. This could be something like a virtual WAN. So, for starters, how do we actually get an NVA into our environment? What's the management process we need to go through? Well, this is going to depend a lot on the virtual appliance you're looking to pick. Ultimately, all of it comes down to picking the vendor offer that makes the most sense for you. Network virtual appliances are third-party appliances, and these vendors have created managed offers that you can deploy into the environment and then configure. So your first place is going to be going to the marketplace in Azure to pick the right thing for your environment. The next thing is to make sure that you've configured your scaling correctly. I'll show you an example of that in just a moment. And once that's done, things will get created for you on your behalf. So the initial management setup is fairly straightforward. The deployment is also fairly straightforward. We can see right here, this is an example for Virtual WAN Hub, and we have a list of appliances on the right-hand side. Far from exhaustive, just took a screenshot. But what you can see here is a range of different appliances that are available for you to deploy and make use of straight away. So if you are currently in the Fortinet ecosystem or are making use of, say, VMware SD-WAN, you can interlink natively with those and continue to use your expertise in those third-party appliances in the cloud. Now, deploying this NVA, there's only really one other thing you need to think of. Of course, we're going to want some sort of security token. This is usually provided to you by the vendor, so you'll need to work with them to acquire that token. And of course, we need to know where we're deploying it, what hub it's going into. But scale units are going to be the most important part. Deploying a network virtual appliance like this is not the same as spinning up a virtual machine. It is something that you are configuring and telling us as a managed service what is the bandwidth you wish to process. Different scale units will offer you different levels of bandwidth processing depending on what it is that you actually require. Simply go through, pick what you need, set it up, and hit deploy, and as a managed service, things will work no problem.